Hey folks, welcome back. In this video we're going to go over question 5 from the 2016 SQA Advanced Higher Physics exam paper. So let's get started. Question 5 says Einstein's theory of general relativity can be used to describe the motion of objects in non-inertial frames of reference. The equivalence principle is a key assumption of general relativity. A part 1 says explain what is meant by the term non-inertial frames of reference. And there's 1 mark available here. Well, we can simply say that non-inertial frames of reference are frames of reference that are accelerating with respect to an inertial frame. And remember, inertial frames of reference are those which obey Newton's first law, which is to do with objects travelling at a constant speed with respect to another. A part 2 says explain what is meant by the term the equivalence principle, and again there's 1 mark available here. Well, we can say it is not possible to distinguish between the effects on an observer of a uniform gravitational field and a uniform acceleration. Part B says 2 astronauts are on board a spacecraft in deep space far away from any large masses. When the spacecraft is accelerating, 1 astronaut throws a ball towards the other. Part 1 says on figure 5a, sketch the path that the ball would follow in the astronaut's frame of reference, and there's 1 mark available here. Now you'll see in the diagram here we have the 2 astronauts A and B, and astronaut A is going to throw the ball towards astronaut B, and we're told that the spacecraft is accelerating upwards in this direction. Well, because both astronauts are in an accelerating frame of reference, then in the astronaut's frame of reference the ball is going to follow a curved path like the one shown here, and you need to make sure you're showing that curve going down the way for 1 mark. B part 2 says the experiment is repeated when the spacecraft is travelling at constant speed. On figure 5b, sketch the path that the ball would follow in the astronaut's frame of reference. Again, there's 1 mark available here. So this time we've got the same 2 astronauts A and B on the spacecraft, but this time the spacecraft is moving upwards at a constant speed. It's no longer accelerating. Well, because both astronauts are now in an inertial frame of reference, i.e. one that's moving at a constant speed with respect to another, this means that astronaut B would observe the ball to follow a straight line path like the one shown here. So we've no longer got a curve, which is the case for the accelerating frame of reference, we've now got a straight line. And you need to make sure the line goes straight across here to get the mark. Lastly, part C says a clock is on the surface of the Earth and an identical clock is on board a spacecraft which is accelerating in deep space at 8 meters per second squared. State which clock runs slower. Justify your answer in terms of the equivalence principle, and there's 2 marks available here. Well, we can say that by the equivalence principle, the spacecraft is moving in a smaller gravitational field than the Earth, i.e. 8 newtons per kilogram in deep space, which is less than the 9.8 newtons per kilogram on Earth. And that's because, remember, the equivalence principle says that gravitational fields and accelerations are equivalent. And therefore, we can say the clock on the surface of the Earth would run more slowly, or the clock on board the spacecraft would run faster. And so that first statement, the clock on the surface of the Earth would run more slowly, that's because, remember, time runs slower in a stronger gravitational field. Or this second statement, the clock on board the spacecraft would run faster, that would be because time runs faster in a weaker gravitational field. That's all for this video folks, thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.